Hi, Jong-ha. Hi, Yong-Yong. Welcome. We're waiting for Karsten and others to attend, the NIPSI folks. So we will give them a moment.
So I opened up the Hedge doc, put the agenda, ready to take notes. You can wrangle your slides, I guess.
Yep, I'll run the slides. Don't worry. And immediately I see the first error. So there's no time travel involved. The wrong date on the slides. Even the wrong interim number. Okay. Hi, Bart.
Hello.
Hi, Karsten. Hi, Karsten.
Hello.
Hello. Yeah. Okay. So thank you for joining. Welcome to this first interim of 2025. As I said to the people join early, when you see the slides up big, you immediately see the arrows here. This is the first interim of 2025, and this is January 28th, not anything else. So here is the first notable page. You are recorded. Please be nice and professional. Please be aware of the IETF code of conduct. And the usual IPR guidelines for IETF apply. There is the repository where we keep our notes, and there is also the link to the notes of today that Michael will be editing. And of course, it's great if you can follow that at the same time as the meeting, so if your comments are picked up correctly. Right, here is the second Notwell page, and you've seen it before, so this is not so interesting. It's the usual Notwell. The IETF Code of Conduct guidelines: treat colleagues with respect, speak slowly and limit use of slang, dispute ideas by using reasoned arguments, use best engineering judgment, find the best solution for the whole internet, and please contribute to the ongoing work of the work of the group and the IETF. And I guess all of you know this already. So here is the agenda for today. It looks a bit I shouldn't say dense, but here are things we have. We've done the Notewell, the logistics. We'll have a quick working group update. I saw that you had some stuff on that in your slides as well, Kirsten, so we'll use them instead. And bake that together with the ASDF status. Then we'll talk a bit about NIPSI. After that, the digital twin non-affordance information draft that Yun-Young just updated. So any other business that people want to add to the agenda? I think we can usually fill the time out. I hear none. Okay. So we were charted in October 2020. We are progressing the first, and so let's, Karsten, I'll leave to you to talk about the ASDF draft in a moment. We have a new charter, and we have another draft adopted, which is a NIPSI draft, and we have the digital twin location draft that is on call for adoption, and that's being discussed quite a bit. So I think we need to talk a bit more about that. We have meeting plans. We have said we will not meet in Bangkok. We discussed that in Dublin. So I suggest we have another virtual interim around the Bangkok timeframe. The reason for not meeting in Bangkok is that many key contributors will not be in Bangkok. So we can take this at the end, but expect some interim in that time frame. Not conflicting with other deadlines for the meeting and so on. Any thoughts about that? The idea is then to meet in person in Madrid in summer. Michael?
I was going to say February 28th, because you already have a slide.
Yes, that's good reuse. I don't know what kind of date that is, but yeah, February 28th is the proposed date. Let's try to use that. Okay, good. Then I will let you, Karsten, I will let you talk about, let me just, if you can take the base ASDF processing 2 first slides, that would be great, Karsten.
Yes. So I made a similar slide a couple of interims earlier in 2024. So the status of base SDF is that we have completed the first IETF last call. There were tons of comments, many editorial comments, which maybe wasn't too surprising because the document really had been focusing on getting the content right as opposed to actually getting the right words in there. So based on this, we have draft revision -19, and the second IETF last call was initiated for that. So this will take, I forget how long. And when that is done, we probably will have a few new review comments. We will likely generate a draft -20. I hope we don't have like 60 detailed editorial comments again like this time. So this should be faster, I hope. And then we go into ISG evaluation, and hopefully we can generate a -21 on that, and maybe a -22. And at some point, I hope we get this document approved. So this is the outlook. I just wanted to point out, can you go to the next slide? I just wanted to point out that even when it's approved, then we still have a few things that need to be done. Right now, the RFC editor is excruciatingly slow. So the 1 to 2 months I talked about last year, that will certainly not happen. So with a lot of luck, we will have summer, early fall publication as an RFC of what's there right now. So that was just to manage the expectations here.
Great, thanks, and thanks, of course, for being persistent and actually pushing this through all the way. It's great to see that we are moving, even if it's slowly, and what we see is some kind of end outcome of this. Very good, looking forward to it. And thanks for handling all those, those edits, quite a number of them, as you said. Great. With that, any questions or comments on that, or? Great. If not, then let us, so we have basically 50 minutes left of this meeting. And I think since there are material both for NIPSI and for the non-affordances digital twins location draft. So I would suggest that we are basically try to split the remaining time in half and take first half 25 minutes for NIPSI, and then the rest for modeling and non-affordances digital twins and so on. And if there is, so make that as a rough kind of planning estimate, and we'll see if we need to adjust during the meeting. Okay, so now Bart, I will try to find your slides. Give me a second.
Just a quick comment on the timing. The meeting ends at 17:15, UTC.
Ah,
So we
yes.
have a little bit more than those 50 minutes you have been talking about. Just wanted to mention that.
Yeah. No, it's good. So we, I guess we usually keep it to an hour, but you're totally right. So if we run over and if people have time for that, we can use that time, but maybe not plan for it. So Bart, if you can try to keep, if we can try to keep the NIPSI stuff under 25 minutes, that would be great, or around 25 minutes.
All right. So this is our NIPSI update, and Nicholas, you're not the only one who gets the dates wrong. I had it on the 26th, so
yeah.
No worries. All right. So next slide, please. Yeah. So quick update. So in December, after the face-to-face meeting in Dublin, where we got lots of good feedback. Also during the hackathon, we focused on updating the Open API model. There was a PR in December, and more comments came. Those were taken into account, and then right before Christmas, we kind of pushed the model to main. In the meantime, we've been focusing on implementing those changes. There's a draft 04 branch, and we've made a few changes to the model. A few things that we figured out during the implementation that we wanted to change, and we've also done quite a lot of updates on the text already, but it's not, the draft 04 text is not quite ready yet. There's a few more updates that need to go in before it goes into main and gets published. So the model, I think, is now okay. The implementation is almost there, and we're finishing up the text. So from a kind of high level view, that's where we are. Now we can dive a little bit deeper into what it looks like. Next slide. So what's new here is that obviously before already NIPSI operations leverage scheme objects, so device or group IDs. These are now in all the APIs in the path, right? This is very useful, as we're also starting to see the larger networks with multiple NIPSI servers, so we can start proxying those requests to the appropriate NIPSI server that is serving that device. The other new thing is that we moved from registering specific properties, events, and so forth, to registering an SDF model that encompasses all of those affordances. So we moved from several registration APIs to one registration API that registers an SDF model. So now basically you need two things in order to do a NIPSI operation. You need an instance, which is delivered by SCIM, and then an interaction model for a device, and then you can basically do a NIPSI operation. We have registration APIs that register a model against the NIPSI server, but there's also we can also include a reference in the SCIM object for a specific group of device to the SDF model that applies to that device. Then the NIPSI operations themselves are either are SDF affordances, so properties, actions, and events. So those basically leverage protocol mappings that are inserted in the SDF model. So that kind of map, for example, a property to a protocol-specific property. For example, in BLE, that would be a service and a characteristic ID. And then there's also the pub/sub interface. That is there we can basically stream events that could either be events from devices, broadcasts from devices, or connection state as well, so devices that are coming and going. And those are CBOR. So obviously NIPSI is JSON, and then these are CBOR based and can be delivered over MQTT or HTTP. Next slide, please. Nicholas, next slide, please. This is new, the SDF model registration. There's a post and a get. So the post registers an SDF model for an ID. The ID is either a device ID or a group ID. So I think in principle, typically these models would be registered for a group of devices. So you can register it for an empty. You can register it for an empty group as well. And then the get operation retrieves all of the SDF models or all of the models for an ID, so that you can in principle register multiple models, and then you can in case that there's you can in case there's contention, you can use the full path to reference them. So the top level of an SDF model needs to be an SDF thing or an SDF object, and then the NIPSI API will leverage all of the affordances, so the properties, the actions, and the events in that model. And those need to contain obviously protocol mappings if NIPSI is to kind of figure out how a property maps to a BLE property or a ZigBee property, so a property of the non-IP protocol. And then there's also another registration, a data app registration, which allows a NIPSI application to register other applications that are authorized to receive specific events. Next slide, please. Then the protocol, this is what the protocol mapping looks like. So we want to make protocol mappings extensible to new protocols by means of an IANA registration. The protocol mappings we've defined so far are, the standard ones: property, event, broadcast, service discovery as well for BLE, and then protocol-specific error codes that go in the responses. Those protocol mappings can be in an SDF model, but they could also, I'll give you a few examples. There's also the possibility to use them directly in a NIPSI API, and they look the same. So it's protocol map, then the protocol, and then the attributes inside it, just like you see in the example here for BLE. Next slide, Nicholas. All right, so once you've registered an SDF model with protocol mapping, you can use the NIPSI APIs. So the first set of APIs is properties. So this basically allows you to get and update NIPSI properties. The assumption here is that if the underlying protocol requires you to do connection management, for example, this is not required in ZigBee, but for example, in BLE, if you want to read or write a characteristics, you actually have to connect to the BLE device. So the assumption is that if the underlying protocol requires you to set up a connection, it is implied that that will be performed as part of the API call. And then basically the property mapping will tell the NIPSI server what BLE property to go read or write. So and the SDF property can then be referenced using a fragment identifier, or if there's potentially contention, the global name can be used. Next slide. Event APIs. So this is an API that allows to enable or disable event reporting on a device. Again, the same thing. If connection management is required, it'll be done. Again, protocol mappings are used here. So the post enables and the delete disables an event, and then a get gets the status of the event, or a state of all events if no specific event is in the path of the API. Again, here all an SDF event can also be referenced using a fragment or a global name. Next slide, Nicholas. And then the last one is the action APIs. So those, just like the name says it performs an action on a device. The operations here also use the protocol mapping, and there's just one API. It's a put because you're performing an action. So there's no other operations that you could do on an action. Next slide. And then there's a few other APIs that we've kind of, as we kind of implemented this, that we saw that we required. So I think that the biggest category here is explicit connection management. And we've implemented this as actions. The reason we have this, and these are basically APIs that do not use kind of registered affordances, but basically have protocol mapping embedded. Is what we've seen is that sometimes when you want to do a number of subsequent operations, it's interesting to do your connection management explicitly. So, for example, you set up a connection, then you do multiple reads and multiple writes, for example, or multiple actions, and then you close a connection. So, in case that you for example do a get of a property and the connection is already there, obviously that connection doesn't have to be set up. And if it's already there, then that API doesn't have to tear down that connection, because maybe maybe the application would like to perform another action or get or put another property. So for those reasons, we've implemented explicit connection management as well. And another API that we've implemented is a broadcast API, which basically allows the network to broadcast a message. This is also not to a specific device, but in an area where a device is. And then there's also a post, like more of a RPC style property write and read with an embedded protocol mapping. There's this basically for legacy reasons, the ability to read or write without a property without registering an SDF model. So these are, I would say, additional APIs that can be leveraged, but are in principle not required for NIPSI operations, the standard NIPSI operation should be able to cover everything. Next slide. Then extensions. So we talked about extensibility from a protocol mapping perspective. And these are extensions that are basically compound APIs. So they're not new NIPSI APIs, but they're basically allowing you to combine multiple NIPSI APIs into one API call in order to facilitate complex operations with a single API call. So again, we feel like we could create new extensions and have them be IANA registered, or even have vendor-specific extensions that can be created and are not IANA registered. We've created a few already. So I think the most interesting one is the bulk API. So this basically allows the execution of NIPSI operations in bulk. So in a bulk API, you basically define the operation. So I get the put, and then the NIPSI API you want to execute. So it could be like a get property followed by a put property, followed by an action, for example. So you can basically define multiple API calls in one API call, execute it, and get the result. Then there's a file as well. So this is a bulk API that allows the transfer of a file across multiple NIPSI operations. So imagine that you need to do multiple writes to write the file to a property. The same with the binary blob as well. Then we have one more, which is kind of a firmware upgrade, which is a combination of a file download and a few other operations. So obviously, there's more extensions that could be defined, but these are the ones that we've already defined and that we've used. Next slide, please.
Yes, I see Michael in the queue. Michael, you have anything?
Bart, do you think that in this space, and it was really about the previous slide in some ways, is there a need for some role-based access control? And if so, do you think that's an SDF extension or a NIPSI specific thing?
Yeah, I think there is definitely a need for a role-based access control. I think at the minimum, right, there's I would say that like the three top level roles could be, who's allowed to onboard the device, who's allowed to execute NIPSI APIs, and who's allowed to receive data. But I think what you're pointing out is that even inside like NIPSI APIs, somebody could be, or an app could be allowed to upgrade firmware, and another app could be just allowed to read and write data, right? That's what you're basically
Well, I was
saying.
even thinking about, I'm allowed to query the state of the lights in the room, but not change them.
Yeah.
Right. And
yeah.
Or that, maybe anyone is allowed to find out the state of the lights in the room, but only the controller is allowed to change them.
Yeah, that's a good point. I think for now we've kept it to, onboarding NIPSI APIs and then subscriptions, right? And have authorizations based on that. But I agree with you. We could go much more fine grained.
Do you think that affordances should just within SDF should describe their sensitivity? I'm not the right word, but there's a difference between firmware upgrade and increase the temperature by 1 degree.
Yeah, I mean, as long as we think that that's not, because if we believe that is like a per device type attribute, then it belongs in the SDF model. If it's a per instance attribute, it belongs in SCIM. But I think it's more of a per device type attribute, so it probably belongs in SDF.
Hey, Bart.
Elliot.
Hey, good afternoon and good morning, Michael. And hi, everyone. I think the question really is, it's one thing to describe it, to describe the authorization. I think that might be an interesting, I don't know if it's RBAC related or something else, but the question is whether that needs to be internalized or externalized to an application. I think ASDF sort of argues for externalization, doesn't it? Right. That is to say, we should describe it, and that should be in an SDF description.
Well, you said externalization, and then that implied it was outside, but then you said the opposite, I thought. I think that each kind of affordance needs to kind of describe its, use the word sensitivity, but I think that's really the wrong word. I don't have a better word, but it kind of goes into different categories, and I think that it's outside in the SCIM space to decide which category a particular client, I guess is the word here, falls into. So I don't expect SDF to describe administrators and users and whatever, but I expect it to say this affordance is more sensitive and this one is less. Arson, just jump in.
Carsten, you want to comment?
Generally, the question who may do what is a business logic question. And generally, we try to minimize actually constrained devices executing business logic. So I'm not entirely sure that the SDF model should describe the actual authorization. But of course, it can actually provide some grouping, some categorizing, as someone just said. So that there are a number of requests that are relatively widely available, and a number of requests that really only the installer should be doing, and a number of requests that require fire department authorization, things like that. And that could be an additional quality in the SDF model that just makes it easier then to write authorization models. So you don't have to actually list all the devices with all their properties in the authorization model, but you can just say, oh, this guy, for instance, if you do role-based access control, this group, this role actually can read the temperature, but cannot change it.
Yeah, so if I'm so you would basically map, like, okay, an attribute there that would say, okay, this is like a fireman authorization, like not particularly who, but the group of or the type of authorization.
So it depends on what you actually want to be able to do in the authorization model. In the end, should be able to do anything, but then it becomes complicated. And the SDF model might be able to provide some receptacles, so you can write a simple model, like this particular role can do all the affordances that were reserved to the fire department in the SDF model.
Yeah. Makes sense.
But there could possibly be even more to that, right? But even before the ASDF group was chartered, we were discussing these safety labels for certain affordances or certain devices, that you could somehow signify that certain operations or actions or stuff would have safety information associated with them. And that would be another way to communicate kind of sensitivity of an API or something like that.
Sure.
Yes, but Bart, please continue.
All right. Well, next slide then. So we kind of went from a single model that's in a single file to like a kind of we broke it up into multiple files. So we now have like an open API definition that is that has all the core NIPSI operations. So in it, so those are the ones that are kind of standardized as part of the draft. Then we've got protocol mappings. So in principle, if you IANA register a new protocol mapping, you can add it here. Then there's extensions, also IANA registered ones, and then under that there's vendor-specific ones that we believe should not be IANA registered, but also not probably be made available in the NIPSI ASDF repo. And then there's the CDDL for the data subscriptions. Then we've in our testing kind of created a few examples for devices that we test with, and we've added those to the NIPSI SDF example SDF or NIPSI SDF example directory, and then so there's basically a few SDF models in there that of real devices that we've tested with and tested the APIs with. What we have not done yet, so as we're in the process of implementation. We haven't so far anybody that's in or any applications that have worked with NIPSI have done so with the kind of individual affordance registrations. They have not done that with SDF models. So now we'll be having our after we've built our own examples, we'll be having our application partners kind of create SDF models for their devices, and we'll see how that goes. I think Ari pointed me to a web-based tool as well, so we'll see if we can have them use that and create a few models for their devices. And if they are okay with it, we can add it to the example area as well. So I think from a model perspective, we're in a good shape, and we'll now continue to work on the draft text, which should be available in a few weeks. And I think I took about 25 minutes.
Okay. Thanks a lot. It's great to see that you've been busy, so very productive. Great. We really don't have much time left for this, but any quick questions? I guess, Carsten, you're first in queue. I don't know if you're still... Okay. Ari, then go ahead. Ari, please.
Okay, thanks. Not necessarily a quick question, but maybe we'll have more time in towards the end to discuss. But I was wondering about what you mentioned, legacy API, the one that doesn't use SDF and has this more detailed communication control. So I was wondering, I guess this communication control part could be used together with SDF style, or are they somehow independent?
No, they are yeah, I mean, like if you do explicit connection management, if you set up a connection, then you execute a get property that will be used, that will use an SDF referenced, that can use an SDF referenced affordance, right? So yeah, absolutely, you can use them together. I think, but I think connection management is important for you if you want to do kind of multiple operations and you don't want to connect and disconnect to the device every time. Right? We saw that because we tried to kind of make sure that when you call a NIPSI operation, right, that it's not necessary for you to set up a connection, call the NIPSI operation, then tear down the connection, right? So if you're really just interested in, hey, give me the status of this light, right, then you just call the API, connection management will happen, and you're done. But if you want to do multiple things, and you're kind of sensitive to how efficient that is, right? You don't want to connect and disconnect for protocols that need explicit connection management. Then you can use these connection management APIs, but you can definitely use them in combination with the standard NIPSI APIs.
Okay, thanks.
Okay, thank you. With that, let's try to... Karsten, can we keep your question to the end?
Just a very quick comment. Connection management, of course, is something that they're quite used to, and there are more things than open a connection, do one operation, close a connection, and explicitly managing connections. So, for instance, there might be timer-based connection management. And I think we just need to think about connection management for a little bit to come up with what we want to be able to specify here.
Okay, yeah, I mean, Karsten, looking forward to your ideas there.
Okay, thanks. Let's move on to the next step here. We actually have two slide sets, one from Hyun-Yong and one more general one from Karsten on modeling. But I think we should, can we start with Hyun-Yong's slides, and then if you can reasonably quickly pass through them, because you've done some updates to your draft, and tell us what we're doing, and maybe we can spend 10 minutes on that, and then the remainder on Karsten's stuff and general discussion. I hope that's okay.
Okay. Hello, everyone. Okay, thank you. Hello, everyone. I'll have a very short talk for the document titled Extended SDF for Digital Twin. In this version 5, we describe the SDF structure for digital twin with reference to Ari's email about merging SDF documents and info block. And there are some slight changes for clarification. After that, we will create and split this document as suggested by Ari at the last meeting. Next slide, please. Okay, this is the status of SDF for digital twin. In this version 5, it is changed as informational track from standard track as Ari's suggestion. Next slide, please. Okay, to extend the SDF for digital twin, we need to consider the non-affordance information such as location, history, relationship between objects, and so on. The purpose of these revisions, we add the SDF structure for location in clause 5.1, and the location examples are corrected for clarification in clause 5.2 from 2 to 5.4. Next slide, please. The first change is the SDF structure in clause 5.1. It was made by referring the Ari's merging example. And next please. And there are some location examples slightly changed for clarification as figure below. And next slide, please. And non-affordance information. To split or create the new document for non-affordance information, we need to define and consider what is non-affordance information, including the definition, examples, necessity, and purpose, things like that. The contributions and comments are welcomed for that. Next, please. In this version, we have changed the track from standard to informational at the suggestions, at the artist suggestion, and we have added ASDF structure in clause 5.1 and slightly changed the documents for clarification. Next, please. Right. For future work, we will develop this document and split or create new document as artist suggestion last meeting. That's it. Thank you.
I guess
Thanks a
I'm
lot.
surprised with that comment about moving from standards to informational. If anything, it should be a working group decision, but I'm not right sure I understand why that makes sense.
It's just the artist suggestion at the last meeting. So artist suggested the another 2 documents more we'd like to develop, and this document will need to be changed from standard to informational. It's about artist suggestion.
Ari, but were saying moving it or changing it to be normative and informative references?
So the suggestion what we discussed in Dublin meeting was that, that we should have probably few different types of documents. One would be a normative document that describes this extension mechanism. And then the informative document is the one that now is being discussed that actually says, okay, here's how you can use it in order to do, for example, a digital twin. That was the idea. So then, now this draft still currently has both components, the normative parts and the informative parts. But if we split it, like we discussed in Dublin meeting, then this becoming informative makes sense.
So informative is not the same thing as informational. That's why I'm.
Yeah, sorry, terminology issue.
Okay, so I just want to be sure that didn't get lost in translation, literally.
May have been getting lost somewhere, but yes.
So are you suggesting that we have an informational document and a standards track document, or you're saying that there's a document that would make normative references and one that would be more informational?
Yeah, so the suggestion that this would be the informational.
Okay, well, I'm not convinced it shouldn't all be standards track, even though one may be more how to use the other tools to do something useful. But anyway, I don't think we have to decide that now.
Yep. Yeah, and I don't have a strong opinion on that either. But the key point being that we do need a normative one, the proper standards track document that describes the mechanism, and whether it makes sense to have those in both, how used for digital twin. That was the discussion. The perhaps may make sense to split it.
Have you volunteered yourself to be involved in the standards track document at this point? Is that true?
Definitely involved. Whether I can drive, that's maybe a bit of a challenge, but I can try to see what I can do for that.
Okay.
Okay, now unmuted. Okay, thanks. Good. Thanks for clearing that out. And as I was saying, thanks a lot for doing these updates and continuing to perseverance to continue working on this document. I think we're getting there eventually. Karsten, you want to say something? Or
I just wanted to get slide control for the next speaker.
oh, okay, cool. just switch the slides. Give me a second. Models. There we go. So,
Okay, can you give me control?
good question. Yes, I guess so. Where?
Click on my name in the chat, in the participant list.
Oh, there. Pass slides control.
Yes.
There you go.
Perfect.
Go ahead, please.
Okay. So basically, I got short notice to talk about the non-affordance aspect, and I'm sorry, but I need about 8 slides to talk about that. So let me quickly go through a number of concepts that we have had in the Think a Thing research group since the OTC meeting in 2016 and the Wishing meeting in 2017. So what we are trying to do here is to generate interoperability. And there are different levels of interoperability, and we need to be aware of which one we are talking about. So there is semantic interoperability, which is about understanding things, structural interoperability, which is about sending data that look like they can be acted upon, and syntactic interoperability, which is about encoding that data right. And I'm going to talk about semantic interoperability mostly, but we will need to talk about the other levels as well. And it's going to come up. So this comes together with the 3 levels of our architecture right now, where we have an information model, a data model, and a serialization. And SDF really has been mostly about the information model, even though it uses vocabulary from a data modeling mechanism, JSON schema org. So we're not at all talking about serialization in SDF. So this is the level where we talk about data, but really we are talking about interactions most of the time. So this pretty well-established hierarchy of data model levels, this somehow needs to be mapped to interactions. And we probably need the same 3 levels here. And I think Bart already has identified the protocol mapping as one part of this hierarchy. But we have to talk about the other levels as well. So my protocol mapping may not be exactly the same that's in NIPSI right now. And I think the NIPSI one is not bad at all. So we will have to discuss this. But I just wanted to open up these 3 layers on the interaction level as well. So the point about SDF was to fill this red star in the middle, so we don't have an M by M situation where we need tons of converters, but we have a single format in the middle that can be used to convert between different models. And these models really are interaction models. So they described how you can interact with a device, and they also describe the structure and a little bit of the semantic information that goes with these interactions. So that's SDF. And when we talked about translating, we always had 2 different things in mind, and it's very important to repeatedly reiterate that. So SDF is for translating data models, which means we have a data model, a Zigbee cluster definition, and we want to get a similar model that is in the meta format. Okay, that's too easy. That is in the lightweight M2M format. So that's about translating data models, model in, model out. The other translation, which is also interesting, is to be able to translate data, actual messages that are sent back and forth between different ecosystem forms of a common SDF data model. So this is what Niklas Meyer demonstrated by using his meta to SDF converter to actually get messages translated between the meta world and the lightweight M2M world. And that is related, but it's not the same thing. And we have to keep in mind that models are different from the data these models are about. Okay, so that was the preliminary stuff, getting some of the terms. And now what we are increasingly looking at is instance information. So we are not describing the interactions that a device of a certain class is supposed to have, but we are actually describing information that is set up differently for every instance of that model. And the obvious thing that is part of the instance information is the identity of the thing. So we have some identity, maybe some address, and there it becomes difficult because you know, naming and addressing are very, very difficult to get right. But that is information that is different. So the model can tell you it's there, but the SDF model, but it cannot tell you what the value for a specific instance, for a specific device is. And there are other things like purpose in life definitions. There are physical aspects. Is this thing installed vertically or horizontally? The device may have no idea, but it's instance information we may want to record along with the identity of the device. So what do we model here? In SDF base, as I said, we have an interaction model that is at the class level. So the interactions being described there apply to all devices. Obviously, the temperature you read from one temperature sensor is going to be different from the one that you read from another temperature sensor. But the model doesn't actually represent the temperature. It represents the ability to obtain a temperature that applies to the device at the moment. So that's the interaction model. And with NIPSI, we are crossing the boundary into modeling interaction messages. So we actually use our interaction model to derive at least an information model level view of what the actual message will be. And then we have to look at things like what exactly do I have to do? For instance, a Bluetooth message formed that can be understood by a particular Bluetooth device. So we have some parts, some aspects of the message model that are implied by the interaction model, because the interaction model already describes the high-level information interaction model, information level model level of that message as the input and output data. But we have to add ecosystem-specific details. So, for instance, the abstract information model needs to be translated into some specific serialization, for instance, using CBOR to represent this information. So that's one aspect here. And the other aspect is not everything actually fits into an interaction model. So as I said, instance modeling requires thinking about devices that aren't really meant to be the subject of an interaction all the time. So you're not going to ask a device, what is your IP address? Because that's not very smart, because you needed the IP address to ask the device that. So there are some data that you want to attach to your idea of what the device is. And some of these you actually can get from an affordance. So if you have a network management model running on that device, it's probably actually going to tell you the IP address. So that's fine. I'm not saying that this is not possible, but that's just one class of information. So there is information the device knows, but the information is very unlikely to know the order number was that was used to obtain this device in 2018. So that's not something that you usually can get from a device. So this may be on an asset management system or on a digital twin. You may have information like when was the device last calibrated or things like that. So this is information that may be available from a different kind of system. So you can still describe it with an interaction model, but you're not actually interacting with the device. You're interacting with a different system that somehow is linked to this device. And we need to be able to model that. And we also probably need to model the process of instantiation. So when you actually create a device or create your representation of a device within your system, you want to be able to say you need this information. So by instantiating, you are creating non-affordance information that you want to have some control over in the model. It just doesn't make sense to have a temperature sensor that doesn't have an IP address you can use to ask it. So again, we can now talk about message models, which is about messages that describe instance information. So not interactions that this device actually has, but aspects of it that are not the subject of interactions, like the purchase order number or the date of last calibration. And so this may be implied by the interaction model, this may be implied by the instance model, this may have ecosystem-specific details, but this is really what we need to talk about when we want to model non-affordance information, because we cannot model this at a class level because the class doesn't have a location. It may have some aspects of a location, but it may not have the actual device-specific location. So this information needs to live somewhere else, and it cannot be described by an interaction model that is meant to describe the device itself. Okay, I hope I have sufficiently confused everyone that you all will be coming to the Think to Thinkergy meeting on Thursday, where we will have a little bit more discussion about this and also about the relationship between different kinds of models.
Great, thank you. Yes, I'm at least slightly confused, so you're successful. No, but thanks a lot for putting this together and reminding us of a lot of the kind of design ideas that went into SDF back in the day. Any comments, questions or so about this, what Carsten just presented? I hear not. Is there something here that we should take up now, given that we have a couple of more minutes, or should we take that for Thursday? Of course, we should have reminded everybody that there is the Think to Think research group meeting on Thursday that will have an interesting discussion on this. Michael?
Proposed in the minutes that we set the next virtual interim date for that Tuesday at the end of February, which was the 25th of Tuesday at the same time.
That works for me.
Okay, so I guess Nicholas and I will put that up into the data tracker.
So how much time do you want to give us?
Well, so an hour and 15 seemed to work this time. There's a late meeting that starts right now, but
yeah. It's maybe on the list actually. So
We'll propose it on the list, and if there's
Yes.
major objections, then we can do something else.
yeah. Let's also work on the list to get the kind of location draft stuff get going. I think
Yeah,
Keenan
I
is
think
doing
that that's
good
a
work there.
critical
So
thing that document get some start points. And I also think would say that if you have any friends that want to become RFC authors, then now's the time to bring them here.
good. Okay, with that, should we close now? Anything else?
Lorenzo didn't talk, and Younghai didn't talk. Do you have anything to add?
Everything is clear on my side. I'll try to join on Thursday, the T2T RG, and then looking forward for custom presentation. And otherwise I've been reviewing a bit of the NIPSI APIs, and I plan to do the same later on.
Yeah, hello, this is Song. I don't have anything to say. Thank you.
Good. Just want to make sure everyone gets a chance to speak if they had something to add.
Perfect. Okay, with that, then I suppose we close. Thanks everybody for today. We had a reasonably large number of attendance, which was great. So thanks a lot, and again, thanks Karsten for pushing those last call comments finally. That was great to see us moving in the right direction. And with that, talk to you again in basically exactly 1 month from now. Thank you.
Thank you. Bye-bye.
Thank you. See you all. Bye bye.
Thank you. Bye-bye.
Thank you. Bye-bye.